Good evening, everybody. My name's Roger. I've been a consultant here with Cardinal for about 4 years now. So recently, I got moved to a new project, and one of the tools that we were using was Docker. And I thought it was really cool, so I thought it'd be kind of fun to share here some of the things that I've learned about developing apps with Docker. So let's start with a general overview of what Docker is. Docker is essentially a container management system. It allows you to take applications and put them into containers, and then you can spin up or shut down containers very quickly. You can also add new ones very quickly. So what is a container? A container essentially is a sandbox for your application that contains everything that it needs to run, right? So this could be shared binaries, config files, whatever your app needs to run. And the cool thing about it is that it also guarantees that the app will run the same regardless of what environment that you're running it in, right? Containers are also incredibly lightweight. Since they share the same OS kernel and RAM, they start nearly instantly, and they use a layered file system so they can share common files between containers, right? Containers are built on open standards. This allows containers to run in a variety of places, including all major Linux distributions, Mac, OS, and Windows. And containers are also secure, meaning that they are isolated from each other, so as well as the underlying infrastructure. So this provides an additional layer of protection for your containers. One of the big questions that people have about Docker is, how does Docker differ from virtual machines, right? So you can see in this graphic that on the left, this is a traditional way of using virtual machines, right? So if you had, say, like a Jenkins server that you were running locally to be continuously monitoring a local Git repo to run long-running unit tests, you might have a image for that. You might have an image for your database. You might have an image for any other external dependency that your application might need, such like an SMTP server or whatever. With Docker, you essentially forego the virtual machine aspect of it. You have a Docker engine, and then each container runs inside of that Docker engine, completely isolated from each other. So you don't have to worry about spinning up. You don't have the overhead of spinning up new virtual machines. You don't have to wait on that. You don't have to have the disk resources or the RAM resources to run virtual machines effectively, right? So one thing to note, though, is that Docker was built for Linux. Docker requires Linux to run, okay? So this is so what happens is when you run it on a Mac or on Windows, you have to have a Linux VM, right? And the Docker tooling will actually take care of spinning up that VM for you and providing that for you. And then the tools also provide the bridge to run commands for your containers inside of the Linux VM. The Linux VM on OS X and Windows, per the website, is incredibly small. It's hosted in memory, takes about 24 megabytes of RAM, and they say it boots in about 5 seconds. Not really what I've seen, but it's still quick enough, right? So let's jump over to KiteMatic, which is a tool. It's essentially a GUI tool for Docker, right? So this is KiteMatic is an application that you can use on Windows or Mac that will allow you to see what containers you have installed. It'll allow you to start and stop them. It'll provide you with some configuration options that you can use. We'll go over that kind of stuff in just a minute. And then it also has a view into Docker Hub, which is where you can go and get pre-canned applications such as Jenkins or Oracle or whatever, right? I mean, there's literally thousands of these things out on Docker Hub, so all you have to do is search for one, download it, and use it. So for the sake of saving a little bit of time, I've already downloaded the Jenkins container. So you can see over here on the right, we have a settings tab. So in here, this is pulling from the container's Docker file to show you what types of options are available for that particular container. You can change some of them if you want. Usually you're probably going to leave most of these the same because they're probably pretty important. But the one thing to note is ports, for sure. So this Mac IP port, this is the IP address of the Linux VM that's spun up. And you can see here that Jenkins has stuff running on port 50,000 and port 8080. Right? So if we had multiple containers that would run on port 8080, we need some sort of way to resolve that. Otherwise, things could, you might get some port binding exceptions. Right? So KiteMatic by default will choose a random port for you when you start it up. So if we switch over here, we'll go ahead and start up Jenkins, and then we'll come back over to the port. All right. And we can see that it chose port 32771. So now if we go over to a web browser, we can hit localhost, or I'm sorry, 32771. 32771. That's a new one. Yeah, here. It's also a little web preview over here, so you can also cheat and click on that link, but I was trying to not do that because I have a bunch of stuff open in my default browser. So apparently I'm typing something wrong. You shouldn't have typed in the HTTP probably. Maybe. I don't know. But so you can see that's all there is to stand up a Jenkins instance using Docker, right? You literally just download the container and start it, right? But what if you want a little bit more consistency around what port it starts on? You can come in here in KiteMatic and you can change these ports. So we'll change that to 9080. And then click Save. That'll stop the container and restart it. And with any luck, maybe I'll be able to come over here. Hey, all right, good. So Jenkins is still starting up because anybody that's worked with Jenkins knows it takes a little bit to start up, right? So it's literally all there is to it. Now, every time you start this container, it will start Jenkins on port 9080 of the Linux VM running on Mac OS X. So this is kind of cool, but if we have a project that we're working on that has several dependencies on external services, surely there's a better way for us to be able to define those for our entire team. So when we onboard new developers, we don't have to say, go grab this image, make sure you get this one because there's probably 25 different Jenkins images out there or containers. Use this one, bind it to this port or whatever, right? So that's where a neat tool called Docker Compose comes into play. So Docker Compose allows you to essentially define what containers you want to start, right? So here's a sample Docker Compose.yml file. Then you can see what it's doing here is it's defining for our continuous integration, it's using the Jenkins image, it's naming the container myJenkins, and it's doing some port mapping, right? So this is mapping port 8080 of the container to port 7080 of the host, which is the Linux VM, in this case on Mac OS X and Windows, right? And then you can see here for mail, we're doing the same sort of deal, except we have multiple port bindings, or port mappings. So SMTP port 25 to 1025 and standard HTTP to 1080. And then of course you can see what we're doing here with Oracle, same sort of deal. So to start that up, Now, all you have to do from a terminal is run docker compose up. Okay, there we go. So now it's going to start all three of those containers that were in the docker compose.yml file. So if we switch back over to Safari, we can see we should not be running on this port anymore, or maybe we do. Maybe I chose the wrong one. We can see mail dev running on 1080, right? And we should be able to see Jenkins running on port 7080. So if we back that out and do 7080, we should see our Jenkins server now running on port 7080. So this is a great way for you to define any external dependencies that your application may need and package that up in a single file that you can bundle with your source code for new developers to be able to just check out a source control and get up and running, right? But another command that's of note is obviously this running just docker compose -up ties up your terminal. So if you add the -d flag to docker compose up, that'll run it as a daemon, which will release your terminal after everything starts. All right, and then everything should be running on the same ports as before. Though that'll probably be booting up because it's Jenkins. And 1080. So that's that. So I thought it was pretty cool. You know, it's a good way to define things for your team and provide a little bit of consistency. So
are you doing all your development in the Docker container? So when you run Tomcat for
you can do that. Our particular application isn't set up for that.
No, would you set it up that way if you're starting something new? Right? Would you build everything up?
Probably depends on what I'm doing. You know,
if
I mean,
someone
it's
comes on board and you want to set up that environment.
Yeah, I haven't really tested it out in terms of like running like a Tomcat instance to develop with.
Like a Tomcat.
But if I were spinning a new project up from the ground up, I would include a Docker file to containerize it so I could stand it up inside of a Docker engine if I wanted to, if I needed to, right? So if our company's using AWS or Azure or whatever, then we can just have, you know, our infrastructure set up to contain a Docker engine. Then all we would have to do is just, you know, pull the Docker image down to that machine and then run Docker, you know, to stand up the container. So I would definitely do it for that. But developing, I know you can. It's not something that I've ever really done. I've really only used it from a external services perspective, right? So standing up.
It works great in there.
Mm-hmm.
But I don't want to have to reconfigure Jenkins over time. Is there a way that I can bring it up and then save that container?
Yeah, so containers by default will save as long as you're starting the same container with the same name. Okay. It'll persist data across, right? So what we're using it for at our client, we use it to run Oracle, for instance, right? Now we don't have to rebuild the Oracle database every single time we start up the container. But we do the first time, right, to load up our schema and our test data, but it'll persist, like if we shut down our computer for the night and go home and then come in the next day. So if you wanted to, you could probably create your own custom Jenkins container with some preset jobs, right? And then containerize that, set it up, ship it out, right?
And it appears that the container concept is pretty much one application per container?
Usually, yes. It's whatever that application would need to run, right? So they might be built off of multiple tools or whatever. So that container might contain some external some other applications that the application would depend the application would depend on, but it would appear as like a single container, right?
Thanks.
So, cool.
So how much storage would normally each container take?
I mean, obviously that's going to vary, but on the application, but they're pretty lightweight, and it's certainly not going to be the gigs that you go in a VM approach would take, right?
So
like a Docker container management system they use in order to create new containers based off other ones?
I don't know. I know typically, yeah, I think it's Docker Compose actually.
Okay.
That's really because you can have a Docker file in the project as well that's going to define what that container would need to run your application. So you can use Docker Compose to string together multiples, right? And even at that, inside of your Docker file, usually the first line will be something that you're going to base it off of, whether it's like an Ubuntu image or like if it's a Java web application, you might build it off of, you might start with the Tomcat container, and then you'll have Tomcat there, and then you'll essentially build and then deploy your app into that Tomcat instance. But I mean, as far as like a graphical tool, I don't know if any of those type of things exist. But they're like Docker file, you can build off of like 1 or 2 containers maybe. So,
Yeah,
and then Docker Compose will allow you to string a bunch of them together.
I was talking about more doing like versioning of your containers. As you have a container, you can make slight changes to that rather than having like keep those as source control. It's not recommended. I thought there was.
So the Docker file is just a text file that you'll package alongside of your application. And if you go and you look at Docker Hub, I think it's hub.docker.com. If you look at some of the images that are out here, they actually are stored out on GitHub. So is this right? Yep. So yeah, typically it'll be a link to you'll store stuff out on GitHub or whatever Git repository.
Okay.
Right? So you can version your Docker file, right? So this is a little bit different than what you saw with Docker Compose, but it does have a little bit of overlap, right? In terms of the commands and stuff that you can do with Dockerfile versus Docker Compose. So
that's only the Docker file that you're storing. You're not storing all the components within that container.
no. So it just describes it, and then the Docker engine will pull whatever.
Assuming it's available out in the.
Yeah, it'll pull whatever containers you need. Okay. All right, I think that does it on time. So, all right, thanks.